If I ask an AI system to plan a factory schedule, drive a car, or manage a supply chain, what does it actually understand about the world it's operating in? Because here's the uncomfortable truth. Most of the AI systems we're deploying today don't understand the world at all. They understand how humans talk about the world. And that distinction is the difference between a system that sounds intelligent and a system that can actually make reliable decisions. Today, we are going to talk about the difference between large language models and world models, why confusing them leads to fragile AI systems, and why the future of AI is not just better chatbots. It is about building machines that can reason about reality. Welcome back. I hope you've been enjoying my recent videos where I'm diving deeper into AI topics. If you have a suggestion for a video, please reach out and let me know. Over the last few years, large language models have become the public face of artificial intelligence. Tools like chatbots, copilots, and AI assistants are now embedded in software products, search engines, and enterprise workflows. And they're genuinely impressive. They can summarize reports, generate code, answer questions, and help people work faster. But when we talk about AI systems that interact with the right real world around us, language models are only part of that picture. There's another class of models that has existed for decades in robotics, control systems, and reinforcement learning. These are called world models. To understand modern AI systems and where they're heading, we need to clearly separate these two ideas. At their core, large language models are sequence prediction systems. They take in a sequence of tokens, which might represent words, pieces of words, or symbols, and they predict the most likely next token. That may sound simple, but when you scale this process across massive datasets and billions of parameters, something interesting happens. The model learns statistical patterns in human language at a remarkable depth. It learns how we explain ideas. It learns how we structure arguments. It learns how we describe systems, processes, and relationships. As a result, large language models can generate answers that look remarkably intelligent. But it is important to understand what's actually happening under the hood. The model is not simulating the world. It is predicting what humans are likely to say next. In other words, language models build an internal representation of language about the world, not the world itself. This is why they excel at things like writing, summarization, and explanation, but it's also why we start to see these answers that sound really good but aren't factually correct. Hallucinations, right? In generating a response that are probable in language and not necessarily true in reality. So now let's contrast that with something very different. A world model attempts to capture how an environment behaves over time. Instead of predicting the next word, a world model predicts the next state of a system. Think of it like this. Imagine an agent interacting with an environment. The agent observes the current state. It takes an action. The environment responds with a new state. Now, a world model learns the rules governing those transitions. If the system does this, what happens next? If the temperature increases, what changes? If a robot arm moves here, what objects will shift? These models are common in areas like robotics, autonomous vehicles, game playing AI, industrial control systems, and supply chain optimization. In these environments, understanding cause and effect is critical. A world model allows an AI system to simulate possible futures and choose actions that lead to better outcomes. Instead of predicting language, it predicts consequences. So now that we've discussed what a language model is and what a world model is, let's look at the differences. For instance, language models are designed to predict tokens in a sequence of text. World models are designed to predict state transitions in an environment. Language models, well, they learn from an enormous trough of human communication in whatever form. World models learn from observations of systems interacting with the physical or simulated world. Language models represent knowledge in a symbolic form. World models represent knowledge in terms of state, action, and dynamics. Another important difference involves time and causality. In language models, time is mostly implicit. In world models, time and causality are central to how the model works. This distinction explains a lot of the limitations we see in today's AI systems. Language models are exceptional at describing plans, but world models are better at simulating whether those plans will actually work. Large language models shine in an environment where language is the primary interface. That includes things like customer support, knowledge management, software development, research assistance, and things like business analysis. In these cases, the goal is not to simulate the physical world. The goal is to interact with people and information. And for that purpose, language models are excellent, very powerful. World models, however, are strongest in environments where decisions affect physical or operational systems. We've already discussed some of these examples, like autonomous vehicles and robotics and industrial automation. In these environments, a system must reason about how actions affect outcomes. And that requires a representation of how the world behaves. The future of AI is not language models versus world models. What I believe is that the most powerful systems, they'll combine both. And that's a super exciting proposition. Language models will increasingly act as the interface layer. They allow humans to interact with complex systems using natural language. World models will serve as the reasoning layer for environments where cause and effect matter. Together, these technologies allow AI systems to do something far more powerful than either approach can do on their own. They allow systems to understand instructions in language, simulate outcomes in the real world, and then make better decisions as a result. Organizations that treat large language models as universal intelligence, they're going to run into problems. Organizations that understand how to combine different types of models will build systems that are far more capable and far more reliable. And that distinction is going to shape the next generation of AI systems. Thanks very much for watching, always. Tell me your thoughts in the comments below, whether you agree or disagree. In my next video, I'll be talking about lazy RAG architecture. I hope to see you then. Bye.